Good morning, Blue Streaks. It is Monday, May 11th already. And you guys have done a great job. I did well on your 13.5, 13.6 quiz, law of sines and law of cosines. I'm real proud of you. Thanks for your hard work. Continue to keep up the good work. We only have two weeks left. So we're going to do one more section. So we're moving back to section 13.3. So we did 13.1 and 2, and then we did 13.5 and 6, and we're going to finish up with 13.3. So again, you guys have done a great job. Let's finish strong. Continue to get your stuff in on time. Remember, my hours are from Mondays and Wednesdays from noon to 12:30. The seniors only have one more week, so that last week I'd have noon to 1 for you guys. And then Tuesdays and Thursdays from 8 to 8:30. And that last week, it would be 8 to 9. So a few of you have popped in to see me and asked me questions. Feel free to do that. But you guys have done a great job. One more section, so let's get started. So just a quick warm up here. In section 13.1 and 2, we did finding the measure of reference angles for each given angle. So if I were to draw that 120 degree angle in standard form, remember we'd always start our initial side right on the x-axis. So there's one side of our angle. And then we would rotate counterclockwise this way. That's the positive till we got to 120. Remember, straight up's 90, straight across is 180. So it's somewhere in between there. So we'll just say, and then what we did is we drew a little arrow, a little arc, and then we labeled it 120. Okay, that's how we would draw it. But we want the reference angle. Remember, the reference angle is this angle here, always between the terminal side, we call this, and the x-axis. So what we're looking for this problem is this reference angle, our point of reference. Okay, so remember, from here to straight up is 90, and from here halfway around, oops, I didn't want to do that, would be 180. Okay. So basically, we're going to do 180 minus 120. And that'll give us 60 for that one. Okay? For the second one, it's 225 degrees. So we are going to, 90, 180, 225 is a little bit more than that. So again, we start here. And we'll end up with our terminal side in the third quadrant right there. Okay, so again, that's 225 from the start to where we stopped. Our reference angle, we'll do it in blue here, is this in here. So we're going to have to do 225, and back to that was 180. It's always between that terminal side and the x-axis. Terminal side and x-axis. So it's 225 minus 180 this time because we went past 180. And that's 45. Okay? All right, so I just wanted to do a quick one of that. We can do it with the other two as well. Negative 150, we'd go this way, because clockwise is the negative direction. Okay, we'd still find the difference between those, which would have been 180 minus 150. Again, so that would have been a 30. The 315, we'd start here and go all the way around because this is 90, 180, 270. Remember, all the way around was 360. So we're over here. And then remember, between the terminal side and the x-axis, all right, we'd go 360 minus 315. So this answer would have been 45. Okay, but just a quick review there. All right. Also, we had to find exact value of trig functions, sine, cosine, tangent, cosecant, secant, and cotangent. Okay. So these were our special triangles I told you to learn. That's what we had a quiz, on 13.1 and 13.2. We quizzed over this as well. And remember, on a 45, 45, 90. If that's 45, that's 45. Remember, these are 90-degree angles on both of these, and a 30, 60, 90. Those were our two special triangles. Okay, so those two sides are equal. So we made those ones, and the hypotenuse was always the length of the side times the square root of 2. So since those are ones, that's 1 radical 2, or just radical 2. Okay, and then we could figure out if this was our reference angle, sine would be opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and then cosecant was a reciprocal of sine, and secant was a reciprocal of cosine, and cotangent was a reciprocal of tangent. Okay, so if we just do since it's a 45 one, we'll do the cosine here, number 7. All right, so the cosine of 45, we're going to use this 45, is adjacent 1 over the square root of 2. Again, we don't want a decimal. A decimal is not exact. It's an approximation. So we want it as a fraction. All right, so don't forget, these answers we're going to be getting on this section will be in radical form, in fraction form. Sometimes we'll get a whole number, not very often, but no decimals, okay? And remember, we can't leave a radical in the bottom, so we're going to multiply by radical 2 over 2. Radical 2, sorry. Remember, that's like multiplying by 1, so we're really not changing it. And this is rationalizing our denominator. 1 times the square root of 2 is the square root of 2. And remember, the square root of 2 times the square root of 2 is the square root of 4, but the square root of 4 we all know is 2. So the cosine of 45 would have been the square root of 2 over 2. That's the exact value. All right, no decimal. All right, we'll do number 8, and we'll use this picture, our 30, 60, 90. All right, cosine of 60, 60 is here. So again, adjacent would be 1. Remember, opposite is straight across. That's the radical 3. And in a 30, 60, 90, remember, we called the short leg was opposite the 30. We made that a 1. And the hypotenuse was always twice as long as the short leg. And the long leg was always opposite the 60. And it's always the short leg times the square root of 3. So 1 times the square root of 3 was the square root of 3. So that was our special triangle. Those two triangles you were supposed to memorize for those first two sections. And if you remember those two, that makes everything easy in trig, if you ask me, because those are the only angles they really ask you about. 30s, 60s, 45s, and then your 90, 180, 270, and 360. Okay, so anyway, for cosine of 60, again, it's adjacent 1 over hypotenuse 2. And we're done. All right, that's the exact value. So it'll be 1/2. Okay, so I just wanted to do a quick review of those that we've done. And, it's been a few weeks because we've been going slow. But, pay attention to these little details. This will help you as we move on. Okay, so we're going to convert angle measures between degrees and radians. So this is something new, probably, radians. We've done everything in degrees so far, but we're going to move back and forth between radians and degrees. And remember, your calculator has different modes. There's radian mode, there's degree. Mine is still in degree mode right now. Okay, and then we're going to find values of trig functions on what's called the unit circle, something new today as well. So we're going to talk about radians and the unit circle. Okay, so here's the explanation about what a radian is. It says, so far you have measured angles in degrees. You can also measure angles in radians. A radian is a unit of angle measure based on arc length. Recall from geometry that an arc is an unbroken part of a circle. If a central angle theta, that's our symbol for theta, remember, in a circle of radius r, then the measure of theta is defined as 1 radian. Okay, so what they're saying is if our arc length is equal to our radius, this angle measure would be 1 radian. When those are the same, that's 1 radian. All right? So it's just another measurement for angles, another way to measure angles. Okay? And the circumference of a circle, remember, like the perimeter of a circle, all the way around it. And the formula for the circumference, when you have a radius r, is the circumference equals 2 times pi times r. Okay, so therefore an angle representing 1 complete clockwise rotation measured 2 pi radians. Okay, so you look at this picture, you know, the red is a 1 full rotation. All right, that's our angle would have been 360 degrees, which is equal to 2 pi radians is what they're telling us. Okay, because we cancel out those r's. If the r's are the same, we get that 2 pi. You can use the fact that 2 pi radians is equivalent to 360 degrees to convert between radians and degrees. Okay, so the blue arc represents 180 degrees, and that's halfway around. So if 1 full rotation all the way around is 2 pi, halfway around would be 1 pi, or just pi radians. All right. And up here I have 90 degrees. If I just went from the red line to this black line, you know, to the y-axis, I'm going half of 180 or 90. You guys knew that this angle is a 90-degree angle. Well, that's half of pi, half of 180. So we call it pi over 2 or 1 pi over 2. And then if we'd start here and go around 3/4 of the way, right, that's 270 degrees. Okay, 180 plus 90 more is 270, which is 1.5 pi, you know, 1 pi plus another half pi, 1.5, or we say that's 3 pi over 2, 3/2 pi. Okay, so those are things you should remember. 90 degrees in radians is pi over 2. 180 degrees in radians is pi. 270 degrees in radians is 3 pi over 2. And 360 degrees is equal to 2 pi. Again, you don't have to put radians after it. You just put, all our answers are in terms of pi when we do it in radians. All right, so when we convert from radians to degrees or degrees to radians, we multiply by that fraction, pi over 180 for going to degrees to radians, and 180 over pi when we go radians to degrees. Okay, so that's our, going to multiply our answers or our degrees and radians by these two fractions. Okay, so here's the first example. We got negative 60 degrees. So when we go from degrees to radians, we multiply by pi over 180. Okay, so that's what they did. All right, so basically what I do is here's how I set up the problem. Here, I'll do it over here to the right. Let's move this a little bit. Okay, but I just write negative 60 over 180, and then I make sure I put pi up here. So then over here, when I reduce this fraction, we get the 1 over 3. And I just do that in my calculator, all right? So I clear that out. Negative 60 over 180. Hit your division sign for over. That gives you a decimal. We don't want the decimal. We want it as a fraction. So we're going to hit our math button. Remember, that'll change it to a fraction. We leave it twice. So we get negative 1 over 3 pi, all right? And we don't, again, have to write the word radians, okay? When you see the degree symbol, you know it's in degrees. If you don't see any symbol, it's in radians. And a lot of times you'll see the symbol pi, 99% of the time, all right? This one, example, we're going from radians to degrees. So we want to get rid of the pi's. So that's how we remember that it's 180 over pi, because the pi's are going to be eliminated. We're going to cancel them. Okay, so I just take the pi, it's out of there, and then I just go 2 times 180 is 360, and 360 divided by 3 is 120. So again, on your calculator, just go 2 times 180, do the top, 2 numerators, multiply, and then divide by the denominator, and then you get your 120. So it's really easy to change from degrees to radians. So angles measured in radians are often not labeled with the unit. If an angle measured does not have a degree symbol, I just told you that, you can usually assume that the angle is measured in radians. All right, so we're going to change this one. Again, when I'm going from degrees to radians, I like to just do this. Divide by 180. Put the pi in the top. Okay, so go to my calculator and go 80 divided by 180. Hit enter, and then go to math and hit enter twice. So it's 4 pi over 9, which we'll see right there. Okay, so that's how I do it. I just go divided by, put the pi next to my degree, 180 in the bottom, and it reduces to 4/9. And then don't forget your pi. All right, again, you don't have to write the word radians. Okay, so then for 2 pi over 9, again, I want to get rid of the radians. We're changing it to degrees. So just do 180 over pi. That way your pi's, oops, that looks like an H, sorry. So then your pi's will cancel. So then you go 2 times 180, 360. Divided by 9, which would be 40. So this would be 40 degrees. Let's use our degree symbol. Any questions? I guess you can't ask them to me. How about you, Tanner Boston? You got a question? Pay attention. Wortman. All right, again, just do it real quick. 180 in the bottom. Put pi in our numerator. Go to my calculator. It was negative 36. Don't forget that. Divided by 180. And then hit math. Fraction, pi over 5. Negative pi over 5. Okay. And then 4 pi radians. Times 180 over pi. So our pi's cancel. And this we go 4 times 180. And our calculator, again, simple. You can do it, no problem. So that's 720, which would be two times around, right? Twice 360. And that makes sense. 2 pi is 1 around, so 4 pi would be twice around. Okay, so that's changing from degrees to radians and radians to degrees. Simple, you can do it, no problem. Okay, the unit circle. All right, so unit circle is a circle with a radius of 1 unit. Okay, so it's, as you can see, here's our center of our circle, 0, 0. Okay, we go out 1 unit. Okay, that's why that point is 1, 0. We went out 1. If we go straight up 1 unit, that point is 0, 1. If we go straight left 1 unit, this point is negative 1, 0. If we go straight down 1 unit, this point is 0, negative 1. Okay, this 1 is for the first quadrant, 2 second, 3 for the third, 4 for the fourth quadrant. As you can see, we got our 0 degrees or 360 going all the way around. We got our 90 degrees here, our 180 there, our 270, and again 360. Okay, so in here we got the degrees. Right behind it, we got our radians. Okay, so as you know, I told you, you have to know your 30, 60, 90 triangle and your 45, 45, 90. So we got our 30 degrees here, which is pi over 6 radians, our 45 degrees, which is pi over 4 radians, our 60 degrees, which is pi over 3, our 90, which is pi over 2. Okay, and as we keep going, 120 is 2 pi over 3, 135 is 3 pi over 4, 150 is 5 pi over 6, and 180 is pi. And then 210, 7 pi over 6 radians, 225 degrees, 5 pi over 4 radians, 240 degrees, 4 pi over 3, 3 pi over 2, and so on. Now, I don't make you memorize this. I make you memorize these. Remember, you're supposed to know those two special triangles. Okay, but when you get to pre-calc next year, they're going to want you to memorize that. Okay, you'll have some quizzes on this. All right, but again, if you know these two things, you don't have to have that memorized. You can figure out every one of those numbers. Okay, now like we did in the beginning, that section 13.2, I believe it was, I gave you a point, and at that point you would draw a line back to the origin and then straight down to the x-axis, and you would make a right triangle. Okay, so if I were to, let's just look at 45 degrees, right? We were supposed to draw a line back to the origin and draw a line straight down, and that would be our triangle we had for our picture. All right, so that meant our reference angle right here was 45. Okay, and that point we were given was like a, let's say it'd have to be like a 2, 2, right? So those would be the same. Remember, so we'd get the same length aside to get a 45, 45. All right, but in the unit circle, the hypotenuse is our radius of our circle. It's always 1, right? Always 1 on our unit circle. So what we have to do is we got to kind of change our two sides. Okay, if we go back to that first slide here that we did the warm up. All right, these were 1s in the square root of 2 for the 45, and this was a 1, square root of 3, and a 2 for the hypotenuse. Well, on the unit circle, hypotenuse is 1, always. Okay, so went far. All right, so I did it making these 1s. All right, so if we're at our 30, 60, 90, okay, and our hypotenuse is 1, that makes my short leg the one opposite 30. Remember, the hypotenuse was always twice as long as the short leg, so 1 is twice as long as 1/2. Or you divide by 2 to go from the hypotenuse to the short leg. So 1 divided by 2 is 1/2. And remember, the long leg is always the short leg times the square root of 3. So 1 times the square root of 3 gives me square root of 3 in the numerator, and 2 stays 2 when I go 1/2 times the square root of 3. So that's what you want to remember now that you're looking at the unit circle for your special 30, 60, 90 right triangle. All right, for your 45, 45, remember this was a square root of 2. Well, we've made it a 1 now because we're on the unit circle. Our radius of our circle is just 1 unit. So our hypotenuse is always 1. So to get from the hypotenuse to either leg, on a 45, 45, 90, we have to divide by the square root of 2. So I did the work up here, 1 divided by the square root of 2, and then I rationalized my denominator. I multiplied by the square root of 2 over the square root of 2. So it comes out square root of 2 over 2. So that's how I got these two sides. So if you memorize the 45, 45, 90 and the 30, 60, 90, you will know what these points are on the unit circle, those coordinates, those x and y coordinates. If we go back up here, all right, we just showed from down here that the x value would be the square root of 2 and the y value would be the square root of 2 over 2, and the y value would be the square root of 2 over 2. So this point, as you can see right here, are those two numbers. So the length of this x side is the square root of 2 over 2, and the length of this y side is the square root of 2 over 2. And remember, the hypotenuse, that radius, is always 1. Okay, so these will fit. The 45, 45 will fit, here, the 135, the 225, and the 315. Okay, the 30 degree fits there, and at 150, at 210, and at 330. So you're going to have these numbers, square root of 3 over 2 and 1/2. And then if you're at the 60 up here, your x value, your short leg's 1/2, and your long leg is radical 3 over 2. And that would be also at the 120, at the 240, and at the 300. So we can draw all those in there. Okay. Another thing that you need to learn about the unit circle is that the sine of that measure of that angle, that reference angle you're looking at, theta, remember, will always be back here, like where I drew that 45, okay, is the y value. R is our radius, our hypotenuse, and it's always 1. So the sine will be y, and the cosine will be x. So all the red numbers are the sines, and they're all the y values. And all the blue numbers are the x's, and those are the cosine values. Okay? If we look at this 45 degree angle, all right, it's adjacent, which is this side, which is radical 2 over 2, over hypotenuse, which is 1. Well, anything divided by 1 is itself, so that's why the cosine would have been the square root of 2 over 2. All right, the sine is always opposite, which if we're looking at the reference angle, always back here, theta is always back here by the origin. Opposite is the y value over hypotenuse, which will be 1. All right, so this opposite side is also the square root of 2 over 2. Divided by 1 is the square root of 2 over 2. Okay? For tangent, remember, it's opposite over adjacent, which is opposite's always the y, over adjacent, which is always the x. Okay? So if it's hard for you to remember which of these two numbers, when they plot the point for you, which one's which, think of the alphabet. What comes first in the alphabet? Cosine C or sine S? Well, you all know that C comes before S in the alphabet, so cosine comes before sine when we're looking at our x, y values, right? X comes before y in the alphabet as well. So cosine is the first number and sine is the second number. Okay, so if you learn that, you got it made. All right, so you can always just look at this picture too to answer the questions that we're going to have for you. So it's really pretty easy. All right, and that's what this was talking about. Cosine's the x and sine's the y. Just think of the alphabet, all right? And as well, x comes before y. All right? So our x is that one when we have an ordered pair. And our y is that one, or the sine, okay? So the diagram shows the equivalent degree and radian measure of special angles as well as corresponding x and y coordinates of the points on the unit circle. So these are all points, again, this is the same picture we've been looking at. Again, in pre-calc next year, you'll have to memorize that. Again, for me, if you memorize those two triangles, you can figure everything out. Your choice. For now, you guys can just look at it, right? Because you're going to have it right in front of you when you do the problems for your homework and practice quiz and all that stuff. All right. So cosine of 225. All right. It says use the unit circle to find the exact value of the trig function. Okay. So if we go back to our picture, 225 is right here. Okay. So there's the point at 225. We're in the third quadrant. Okay. And remember, this is the cosine, the blue one, the ones that comes first. Oops. And the red one is the sine. All right. Since we're in the third quadrant, if I drew a picture of a triangle, my x value would be negative and my y value would be negative if I drew that triangle. It's at 45, 45 if we drew it in. Okay. So they're the same because it's isosceles on a 45, 45. They're both negative. So we were looking for cosine. Okay. So cosine's the x value. All right. So that's what they're looking at here when I pull the screen down. All right. They're looking at that point on the unit circle. Remember, the cosine is the first number. So the answer to this problem is negative radical 2 over 2. Simple. Next one, 5 pi over 6. What I usually do is I'll change it to degrees and I'll draw a picture of it. I won't look at the unit circle. Remember, we're looking for exact values. All right? So if we go back to the picture, 5 pi over 6 is right here. It's in the second quadrant, 150 degrees. All right? This point is negative radical 3 over 2 and 1/2. Remember, the x value is in the second quadrant, so it's negative. The y value's in the second, it's up, so that's positive. Okay, so you got to pay attention to the signs. All right, we're looking at tangent, right? And remember, we learned that tangent was y over x. If I drew a picture, opposite y over adjacent x. Okay, so I'm going to have to do those two numbers. Okay. It's always sine over cosine. You can think of tangent. I'll write that here. I'll do it on this one we're doing. All right. Tangent equals opposite y over adjacent x. All right. So at 5 pi over 6, if you look at the unit circle, these are the two numbers for that point. Okay. Again, go back to the picture quick. Here's the two numbers. All right. That's where they got that, from that point on the unit circle. All right. So that's where that came from. So they're going to take the y over the x. Right. They have it there. So the y is 1/2 divided by the x, negative radical 3 over 2. Remember, when you divide two fractions, it's much easier to multiply by the reciprocal. So they did 1/2 times, and they flipped it, and the 2's will cancel. All right, so they didn't show the work part here. All right, let me show you. All right, so these become 1's when they cancel, right? So this is 1 times 1, which is 1, and 1 times the square root of 3. Actually, there's a negative there. Let's say 1 times negative 1, so it's negative 1, and 1 times the square root of 3 is the square root of 3. Remember, when we're writing in radical form, no radicals in denominators, so we rationalize the denominator. So that's how it comes out to the negative square root of 3. Negative 1 times the square root of 3 is the negative square root of 3. And radical 3 times radical 3 is the square root of 9, which is 3. We got rid of that radical in the bottom. Okay? Piece of cake. All right, 315. We're in the fourth quadrant then. Again, if I go back to the picture of the unit circle, 315's over here in the fourth quadrant. All right, the point that it goes with are these two numbers. The x this time is positive, and then we're going down on the y's, so that's negative. So those are my two numbers, okay? So that's what they're going to give us, and then we're going to figure out what we got to do here. All right, this is sine. All right, sine is the y, right? Our y value. All right, so that's why it's negative the square root of 2 over 2. So it's that easy. You can just look at your unit circle, okay? Again, if we were in class and that, I would be telling you to draw pictures of your triangles and do it that way. Then you never have to look at the unit circle, okay? But since you're at home, you're going to have that in front of you. Just use the unit circle to find your answers. Okay, 180. All right, so again, if we're looking at our picture, 180, remember, is halfway around. That's over here. That point is negative 1, 0. Remember, this circle has a radius of 1. So when we're on either x or y axis, it's just 1 in that direction. So since we went left for 180, it's a negative 1, 0. All right, so they're going to use those points to answer this question. All right, negative 1, 0. So remember, tangent was the sine over opposite, the y over adjacent, cosine, the x, right? Y over x. So the y value is 0. That's where they got that. And the x value is negative 1, and 0 divided by anything is 0. Okay, so the answer to that is 0. Okay, so again, we have to find the exact answer. All right, no decimals. Remember, radical form. Okay, 4 pi over 3. Again, if we go to the picture and look at the point, it would be negative 1/2 negative radical 3 over 2. That is in the third quadrant. Okay, again, let's just pop back. And it's not going to let me. All right, so anyway, cosine is, cosine comes before sine in the alphabet, x before y, so cosine is the x value. All right, so it's negative 1/2, what our answer is, which I can't get it to go any further. Let's see. Take my word for it. All right, the answer is negative. All right, so what's happening here is I'm going to get out for a second. And go back in. It kind of froze on me there. All right, but hopefully this isn't too much for you. Again, just look at the pictures. All right, so 4 pi over 3. Let's just get rid of that. All right, so again, cosine is the x value of the point, so it's negative 1/2. All right, so here's your homework assignment. It's due the 13.3 reading strategy worksheet. I will post that worksheet. It's not very long. You're just filling in the blanks. You're looking at a picture of the unit circle. Remember how to change from degrees to radians, and radians to degrees. Degrees to radians, you're going to multiply by pi over 180. So just make a bar underneath the number of degrees, put 180 in the bottom, put pi in the numerator, and then reduce your fraction. And then when you go from radians to degrees, you're going to multiply by 180 over pi, so the pi's cancel. And then multiply the two numerators together and divide by the denominator, and that'll give you your degree measure. Okay? So again, keep up the good work. Have a good day. You guys have done a great job. Remember, look good, feel good. You are good. You either get the bear or the bear gets you.